let's discuss our tutorial for the third question. Okay, for the third question, we are going to discuss about the cis-trans isomer, or we can call it as a geometrical isomer. So we know that there are two essential requirements for a compound can exhibit as cis-trans. Okay, where the first requirement is we must have a carbon-carbon restricted rotation. So how to identify the carbon-carbon restricted rotation? Okay, we have a carbon-carbon double bond in alkene and also carbon-carbon single bond in cycloalkane, okay, which is our cyclic compound. Alright, so the second requirement, at each carbon-carbon restricted rotation, okay, we must have a two different atom or group of atoms attached to it. So let's have a look at for the first example. So let's say you are given this condensed structure. Okay, don't panic. Okay, just label the structure. Okay, label the carbon 1, 2, 3, and 4, and then take out the carbon that contains the double bond. Okay, so we have carbon number 2, okay, is bonded with carbon number 3, okay, as a double bond. Alright, and then try to expand, okay, what we got on this carbon. Okay, because these two carbon, we call it as the carbon-carbon restricted rotation. Okay, if you remember the first requirement, we must have a carbon-carbon restricted rotation. Okay, so this carbon-carbon double bond, okay, is the carbon-carbon restricted rotation. So we already passed the first requirement. Okay, so now let's have a look at what we got on these two carbon. Okay, for the second carbon, right, so we have one hydrogen and one methyl. Okay, so we have one hydrogen and the other one is a methyl. Okay, and then for the third carbon also we have one hydrogen and one methyl. The second requirement, we must make sure that these two carbon attach to two different things. Okay, so here we have hydrogen and CH3. So it is two different things. Okay, hydrogen and CH3. So these two carbon attached to two different things. So it means that this compound can exhibit as cis-trans. Since this compound can exhibit as cis-trans isomer, so now we are going to draw the cis-trans isomer. Okay, for the cis isomer, alright, we draw the cis isomer first. Okay, first take out the carbon-carbon double bond. Okay, and then just take out these two bonds like this. Right, and then, okay, the first bonding we put as hydrogen, and the second bonding, this carbon is bonded to the CH3. Okay, also for this carbon, so we have hydrogen, and then this carbon we have CH3. So since these two hydrogen, okay, are side by side, okay, we have an identical atom side by side, we call it as a cis isomer. Next, to draw the trans isomer, so again, just take out this, okay, and then just copy back the carbon at the left. We have hydrogen and CH3, but this side of carbon, okay, we are going to change the position of H and our methyl group. So we put CH3 on the top and hydrogen on the below. So here we can see that our hydrogen is not side by side. It's like a cross here. Okay, so this is a trans isomer. For the second structure, okay, again, just label the carbon. Okay, so we have 3 carbon, and then take out the carbon-carbon double bond, which is on our second and third carbon, right? And then for the second carbon, we have one hydrogen and one methyl. Okay. But then for the third carbon, okay, we have 2 hydrogen. Okay, so for the first requirement, it passed. So we have the carbon-carbon restricted rotation. Okay, for the second carbon, yes, it passed because we have 2 different atoms attached to it. Okay, but the third carbon, we have 2 same atoms attached to it. So it does not pass the requirement. Okay, so for this molecule, no, it cannot exhibit as cis-trans isomer. So since it cannot exhibit as cis-trans isomer, so we don't need to draw the cis-trans isomer for this molecule. Alright, for the third molecule, we have a cyclic compound. Okay, each carbon, okay, on our cyclic compound, it is a carbon-carbon restricted rotation. So we already passed the first requirement. Okay, but for the cyclic compound, we have to make sure that two of the carbon regarding the position of the carbon, okay, the two of the carbon must attach to two different atoms or group of atoms. Okay, if you look at here, okay, this carbon is already have two bonding, and then the other two is hydrogen. Okay, so we have hydrogen, hydrogen. Same goes to this carbon and also this carbon. Okay, so this 4 carbon does not pass the second requirement, but for this carbon, so we already have 3 bonding, and another bonding is actually the hydrogen. Same goes to this carbon. Okay, so since these 2 carbon, okay, have 2 different atoms, alright, attached to it. Okay, so yes, this molecule can exhibit as cis-trans isomer. Now, let's learn on how to draw the cis-trans isomer for the cyclic compound. Okay, just copy back the structure. I try to draw it as it looks like on the plane. Okay, so just take out the atoms that bonded to these 2 carbon. Okay, so we have 1 hydrogen, 1 bromine. Same goes to this carbon. We have 1 hydrogen and also 1 bromine. So since these 2 hydrogen is side by side, so it is a cis isomer. For the trans isomer, just change the position of Br and hydrogen for this carbon and then label it as trans isomer. For this structure, okay, just take out this carbon-carbon double bond first, okay, and then if you notice at this carbon we have 2 CH3, but then at this carbon we have 1 hydrogen and 1 CH3. Since even though it has a carbon-carbon restricted rotation and this carbon passed the second requirement, but this carbon does not pass the second requirement, so no, it cannot exhibit as cis-trans. Okay, for this structure, okay, we have 1 methyl and 1 hydrogen. So even though we have 5 carbon-carbon restricted rotation, only 1 carbon that attached to 2 different atoms or group of atoms. So again, no, it cannot exhibit as cis-trans isomer. So that's all for cis-trans.